This is an iHeart podcast. Guaranteed human.
Hey folks, owning a home means one thing. Something's gonna break. AC, plumbing, fridge, and it's never convenient or cheap. That's where American Home Shield comes in. An AHS Home warranty can help protect your wallet from pricey breakdowns on even your oldest appliances and systems. And if they can't repair the covered item, they'll replace it. So check out American Home Shield and get 20% off any plan at ahs.com/SYSK and see promo details. See ahs.com/contracts for coverage details, including service fees, limitations, and exclusions. American Home Shield. Don't worry, be warranty. Stuff You Should Know is brought to you by Grainger. Grainger knows that if you're an HVAC technician and a call comes in, you need a partner that helps you find the right product, fast and hassle-free. And you know that when the first problem of the day is a clanking blower motor, there's no need to break a sweat. With Grainger's easy-to-use website and product details, you can be confident that soon you'll have everything humming right along. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Hey everybody, we are coming to a town ostensibly near you, so putatively see us.
That's right. May 29th, we'll be in Boston, really Medford, Massachusetts. The next night, we're going to go down to Washington, D.C., and then scooch back up to New York City at Town Hall on May 31st.
Yeah, and if you're one of those people who likes to plan way far in advance, then you can go ahead and get tickets for our shows in August. We're going to start out where, Chuck? We're
going to be in Chicago August 7th, Minneapolis August 8th, then Indianapolis for the very first time on August 9th, and then we're going to wrap it up in Durham, North Carolina, and right here in Atlanta on September 5th and September 7th.
Yep, so you can get all the info you need and all the ticket links you need by going to stuffyoushouldknow.com and hitting that tour button, or you can also go to linktree/SYSK Live. We'll see you guys this year.
Welcome to Stuff You Should Know, a production of iHeartRadio.
Hey, and welcome to the podcast. I'm Josh. There's Chuck, and Jerry's back. We don't know if you guys do or not, but Jerry's back because, guest producer Ben was sitting in for a while, and now Jerry's back. So everybody, Jerry's back, in case you hadn't heard.
And we're back from a break. I had spring break, and you had spring break. You're welcome.
Yeah, thanks a lot. Thanks a lot. Where'd you go?
One of us gets a kid. We all get a kid.
Yep.
I went to Isle of Palms again for the first time in like 4 years.
Very nice.
And it was great. It was good to be back. I love that place.
Did you get arrested again?
No, I never got arrested there.
Oh.
What are you talking about? I've never been arrested anywhere.
I know. I just wanted to throw everybody off.
Oh, okay.
The casual listeners are like, oh, Chuck got arrested before? Okay.
Yeah. Dig it up, people. It doesn't exist.
So I am really excited about this one, Chuck. It'd been on my list for a while. I think I came across a top 10 list about like 10 weird things about atomic clocks that How Stuff Works writer named Patrick Kiger wrote.
Yeah.
And I just had it on the list, and but I hadn't really read it enough to know what was going on. And it wasn't until I started digging into the research that I was like, these things are really interesting. And the idea of our modern world, I sound like frozen caveman lawyer, but it's true. Like everything from air traffic control to the internet to basically everything except talking to one another on cans connected by string.
Right.
You can thank atomic clocks for it. It just simply wouldn't be possible without the atomic clock.
Yeah. And by saying that, what you're saying is, and we'll dig into this more later, is that the world, for everything to operate correctly in a tech-forward world, it has to be synchronized.
Right.
And you can't synchronize something unless everybody agrees on what time it is. Mm-hmm. And that's all an atomic clock is. It is very simply, and we'll get into how these things work, which sounds difficult, but it's actually pretty simple still. It is the most accurate timepiece on planet Earth. And it is a self-correcting clock that uses old tech in a way in the form of quartz crystals.
Oh, you gave it away.
Well, I mean, this is the first thing we're going to talk about probably. Quartz crystals, which is old tech, and it is constantly being checked and corrected using new tech in the form of the element CCM-133.
Yeah, very, very well put.
So it's just a clock that sets itself very often and accurately.
Yeah, because everybody who's ever had any experience with a clock or a watch or something like that knows that it can gain or lose time. It can drift, essentially.
You know what they say, though?
What do they say?
Even the worst clock is correct twice a day.
Yeah, they do say that.
Yeah.
So you mentioned quartz, right?
I did.
That's a big deal. And what quartz is, I had no idea what quartz was in a watch or a clock. I just had seen quartz and,
quartz watch.
It was like decades before I realized it wasn't a brand. They were saying, hey, there's quartz inside.
Uh-huh.
And what they're doing is boasting about how reliable their clock is. Because when we used to use things like mechanical stuff, like springs that you would wind that would power a bunch of gears, and that would kind of
gears.
Yeah, the movement of the gears would tick off seconds, right?
How do gears work, though?
Oh, we'll get into that in a different episode, right? Or you had a pendulum ticking off time, something like that. And then when we moved to quartz, what quartz does is it ticks off time as well, because we figured out I don't know who tried this first, but if you apply an electrical current to quartz, you mechanically disfigure it. It's called the piezoelectric effect. And after you, I guess as a result of that contortion, it emits energy. It's like its way of saying uncle. And when it emits energy, it emits it at a really reliable frequency. And we figured out how to use that reliable frequency to tell time. And it's pretty nuts how complicated clocks are, and just how it to me falls in line with that Arthur C. Clarke quote that any sufficiently advanced technology will be indistinguishable from magic. I think applying electricity to quartz to keep time is right up there with that kind of thing.
Yeah. You mentioned it's a piezoelectric material, and we apply electricity to it just to affect it. Like you could bend quartz or smack it or flick it with your finger or something. Any kind of mechanical stress on it, and it would do the same thing. It would produce an electrical charge that's going to come out in pulses. And what those pulses do is they, in the terms of a clock or a watch, is they mimic the swinging of that pendulum. But in this case, like a pendulum ideally swings at once per second. In this case, it's 32,768 pulses per second that quartz crystal is emitting. And you talked about whacking it or something. It looks like, if you look at like the quartz they use, it looks like a little tiny tuning fork.
Oh, neato. I hadn't seen that.
Yeah, it's just a little itty bitty tiny tuning fork. And just like you would whack a tuning fork and it would, whatever a tuning fork does.
It goes wah, wah, wah,
yeah,
wah, wah, wah.
That's not what this is about. But that quartz does the same thing. And we'll come back to that 32,768 pulses per second a few times, because the whole idea with the development, and as we get into history here, of the atomic clock is the more little pulses or ticks that you have, the more accurate within a second of time, the more accurate a clock is going to be. And the development of the atomic clock has always been about just making that number as large as possible. And I guess we shouldn't reveal where we're at now, but it's in the matter of billions.
Well, so if you start from say like an old grandfather clock, as a pendulum swings from one side to the other, that's a second, right? Yeah. And we'll call that a tick. It ticks off a second by swinging from one side to the other. And if that pendulum is off just a little bit, say by 1/10 of a second, right? Every 10 seconds, it's going to lose a second, right? Yeah. Because it has far fewer things to tick off. It has one tick per second. And like you were kind of hinting at, with crystals, you have 32,000 plus ticks per second. So if it misses one tick out of if it misses 1/10 of the ticks, that's far fewer in total than it is to that one tick or that 1/10 of a tick that the pendulum is missing. And so the more accurate the clock is, the more it's what's called stable. And that's the goal of super precise clocks. Stability, which is it's going to measure a second exactly the same now as it will 10,000 years from now. That's stability, and that's the goal. And that's why we've started to turn to things like the atom, which if we can figure out how to measure the atom accurately, it's going to release X number of ticks every time anywhere in the universe if we can measure it when it's excited. And that's kind of where we're at with atomic clocks.
Yeah. And if you're wondering, in the terms of analog technology with watches and clocks, they fall out of whack for a number of reasons, mainly because it's analog technology. Like a spring gets weaker over time. Gears can come out of balance. Even when it comes to crystals, like when they got the quartz crystal involved, that was pretty good. Like 32,768 pulses per second. Like that's not too bad at all. But they quartz can gunk up a little bit because it's a naturally occurring thing. And we'll talk about where you find that in a minute. And temperature, atmospheric pressure, all of these things can throw even quartz out of whack, right? Because it operates really well, basically at room temperature. But once you start applying, really cold, like a watch in the really, really cold weather, an analog watch, or really, really hot weather isn't going to be as accurate. So all of these things, again, for many, many, many hundreds of years, like all this stuff was fine. Because they just needed to tell time and get it pretty darn close, and that was good enough. But when we started going into space, when we started launching satellites, certainly when the internet came online, we started using GPS to do things like, A, get you places, B, unfortunately, bomb hopefully the right place from a satellite communication in a war. Being off a little bit can cost human lives and lose a lot of money in other cases. So accuracy and that stability was a really, really important goal to reach.
Yeah, I found a really good kind of comparison of why that's so important, that accuracy. So like with a quartz clock or a watch, it might lose 15 seconds over 30 days, which is not bad. If you're running a train schedule, a quartz watch will do just fine, right? But if you're trying to, like, say, land a lunar lander on the moon, if you're off by something like a millisecond, you might overshoot the moon by like 200 miles, 300 or so kilometers, just by a millisecond. And a lander needs to be accurate within like 100 meters. So a millisecond off in your calculations can make you miss your spot by like 3,000 times. That's not good at all. So that's why we need this kind of accurate stuff. And there's all tons of applications, like we'll talk about it later. But it just kind of goes to show like just how vital time is when you start using it as a factor in really heavy formulas, which are the kind of formulas they use to land landers on the moon, the heaviest.
Yeah, I got one more for you. A microsecond, even just a microsecond. An error in the order of a microsecond can be a 300 meter or about 320 something yards difference. So that's still a lot.
Yeah, sure. So again, you need precision, and people have been working for quite a while now to make clocks as precise as possible. Do you want to like take a break and then start talking about the history of the atomic clock?
I think so. I think that was, maybe one of our best setups ever, between you and me. I don't want to get this out on the air, but
okay, all right.
This is just us talking.
We'll edit that out.
All right, we'll edit that out, but I think we're on the right track.
Okay, well, we'll be right back, everybody.
Stuff you should know.
Hey, everybody, we're here to talk to you about Wayfair, who believes that spaces should be functional, they should be comfortable, they should be well-designed, and they can be well-designed by you with their help.
Your updated space should feel more comfortable, inviting, and practical for everyday use. And we're talking about outdoor seating. We're talking about grills. We're talking about major appliances. If you need storage solutions, Wayfair can help you out. Patio lighting, rugs, decor. It is your one-stop shop for home.
Yeah. I mean, it's getting nice out, so it's time to think about living outdoors for the next few months. And Wayfair knows that outdoor furniture, it's heavy, it's intimidating to assemble. So Wayfair has stepped in and said, we're going to handle the hard part so you don't have to.
That's right. You can shop Wayfair Verified, your shortcut to the good stuff. And that means their team of product specialists are going to vet everything by hand using a 10-point inspection, testing things like, quality materials, functionality, and features, and even how long it takes to build that piece of furniture. And the overall experience save time, reduce hassle, and improved convenience.
Patio season is here, and these deals won't last. So head to wayfair.com right now to get your outdoor space ready for way less. That's WAYFAIR.com.
Wayfair, every style, every home.
Introducing the all-new Mazda CX-5, featuring more connection.
Hey Google, where's the nearest Pilates class?
Safety that has your back. More discovery on the scenic routes. More passion in the details. And more control in changing weather. The all-new Mazda CX-5. More to move every side of you. See it in 5 films at MazdaUSA.com/5sides.
Google is a trademark of Google LLC. Sequences shortened and simulated.
Dell PCs with Intel Inside are built for the moments that matter, for the moments you plan and the ones you don't. Built for the busy days that turn into all-night study sessions, the moment you're working from a cafe and realize every outlet's taken.
Yeah, the times you're deep in your flow and the absolute last thing you need is an auto update throwing off your momentum. That's why Dell builds tech that adapts to the way you actually work. Built with a long-lasting battery so you're not scrambling for the closest outlet, and built-in intelligence that makes updates around your schedule, not in the middle of it.
That's right. They don't build tech just for tech's sake. They build it for you. Find technology built for the way you work at Dell.com/Dell PCs. Built for you.
So we have a very famous physics professor named Isidore Rabi, who turned down the job of being Oppenheimer's right-hand man at Los Alamos for the Manhattan Project, and instead went off and did his own thing. And one of the things he developed is he discovered nuclear magnetic resonance, and he figured out that's used in the Wonder Machine, the MRI. That's how it does its thing. He figured out how to train that into, or how to use it to great effect in what's called an atomic beam magnetic resonance, which essentially is a way to trap and push around and excite atoms that you want to specifically mess with. That's maybe the 10,000 feet version of what atomic beam magnetic resonance is.
Yeah. And when we're going to say things like exciting atoms, that just means they're moving around.
Yeah, so I guess we could toss it out real quick. Now, an atom has a ground state, which is its resting state, and an excited state. And it can have multiple excited states, but it's either resting or in some sort of excited state or other, right? So Rabi was like, hey, this nuclear beam, I have a feeling you guys could make an atomic clock out of it. And everybody said, you guys, why don't you make it? And he said, you go make it. I heckin' dare you, was his famous quote.
You do it. No, you do it.
So somebody went off and did it. Yeah. And I think within 4 years, the National Bureau of Standards, which is now the National Institute of Standards and Technology, they said, we've got this. We did it, Rabi. And he's like, what are you talking about? He had terrible forgetfulness.
Yeah. Yeah, they said we built the first atomic clock, and this is the earliest version, used ammonia as the molecule and the source of the vibrations. So they were using copper piping to heat it up and shoot it out. It was, compared to what we have today, very rudimentary, but it worked pretty well as a proof of concept, as in, hey, we can do this. But it was a little bit off. I think it was about a second every 4 months, better than quartz, but still not as good as we needed to get to. But again, it proved conceptually that an atomic clock was a thing that works better.
Yes, for sure. But what's strange about ammonia is it has a lower frequency, so there's less ticks per second than the quartz crystal does. It has 23,000 ticks per second, or 23,870 hertz, right? But like you said, they figured out that, yes, you can use an atom to keep track of time, but they're like, we got to find something better than that. Let's try cesium. And in
Everyone went,
1952, yeah, exactly. I could not find anywhere why they decided on cesium. I know it's like neutral, and maybe it's like maybe because it only does have two states, either ground or excited. I'm not exactly sure why, but it's a really weird element, and it's difficult to work with, especially at like room temperature, because it can just suddenly catch fire if it wants to.
Well, I saw why they used it. You'll be glad
why?
to know.
Yeah.
Well, all of this stuff has to deal with oscillation, which is basically whether it's a pendulum swinging or that spring moving the gears. Oscillation just means something that's moving back and forth at a regular rate.
Mm-hmm.
And it turns out that cesium-133, and when something is oscillating, and when you're speaking of like a clock or a timepiece, that's called a frequency reference. Like you're literally referencing a frequency that needs to be steady.
Mm-hmm.
And cesium-133, they found, just was the most consistent frequency reference that they could find in nature. And that was important because using something natural meant that humans all of a sudden were taken out of the equation for the first time, which was a breakthrough, because it's like this stuff is consistent till the cows come home, and human hands aren't making it so.
No, the only thing that humans have to do is to figure out how to excite it. And then once you get it excited, it's going to do the same thing every time, like I said, anywhere in the universe.
Yeah.
And then how to measure it. And those are like the advances in atomic clocks, figuring out how to more accurately measure cesium atoms once you get them excited. That's kind of like the advance. Once they figured out how to excite cesium and then how to measure it, they had the first atomic clock all the way back in 1952. The thing is they started kind of advancing by leaps and bounds, because with cesium, I think, do you want to go ahead and reveal like how many ticks cesium gives off every second?
I guess we should, huh?
I think you should take it, man.
All right. So it was 32,000 and change for quartz.
Mm-hmm.
For that pulse, cesium-133 oscillates at 9,192,631,770.
Right.
That's, I think we would all agree that's quite a jump from 32,000 and change.
It is. And like you said, oscillate is something that is just moving back and forth. It can also oscillate up and down. And if something oscillates up and down, what you're talking about is a wave. And if you put a bunch of waves together, you have a frequency, right? If you have a point in space that you are detecting a wave passing, and you count how many pass in 1 second, you're tracking the frequency of that wavelength, right? Which I think in that sense is a hertz. Whatever happens in a second is a hertz. That's the old slogan.
Yeah.
And so if you could see the waves coming off of a cesium atom as it returns back to its ground state, it got really excited and it shoots off a photon. And the photon itself has waves where if you could just stand still and watch it pass and count the waves, you would count 9,192,631,770 waves pass by you in exactly 1 second. And it became so clear that you could literally set your watch to this kind of thing if you could figure out how to measure it, that back in 1967, the international community said, let's just attach the second to the cesium atom.
Yeah.
And the cesium atom said, I better get some money for this.
Yeah, like let's literally redefine what a second means based on this cesium-133. Prior to that, it was based on like, you know, the sun coming up and going down. It was a solar day.
Right.
So it was 1/86,400,000th. Man, that's really hard to get my head around.
For sure.
1/86,400 is the average length of a solar day, just that little fraction. So they said, let's just redefine it. And I think we should go through a little bit sort of the jumps that they made.
Yeah, I agree.
Because this is all just kind of like, I mean, who cares about this? What people really want to know is how much more accurate was this stuff. In 1959, I believe 1955 was the first cesium-based clock. Mm-hmm. And then in 1959, they had an error rate of 1 second per 2,000 years. 5 years later, it was a second every 6,000 years. It could lose or gain a second. Let me see. What's the next one? 1999. Well, let's go to the mid-70s first.
Yeah.
It was 1 second every 300,000 years. And then finally in 1999, when they debuted the cesium fountain, which that's still what they're using today, right?
Yeah, that's kind of the general state of the art. Although
Yeah.
they're just still looking into new stuff too.
How much better do you need to get it, though?
They're getting it pretty good.
So 1999, it became you could lose a second every 20 million years.
Wow.
And then by 2013, they said, we can actually go back in time and say that using this method, we have not lost a second since the Big Bang.
Right. So that last one you mentioned is a strontium lattice clock, which is, again, we just talked about once we figure out how to measure the vibration of an atom, once it's excited and returns to its ground state, it's just a question of becoming better and better at measuring it. And so they figured out that if you hold strontium atoms in laser beams that form a lattice, you can basically hold them in place and measure them much more accurately. And so that's what represented that crazy, amazing leap. And I was trying to figure out, like, how can they say, like, this thing would not have lost a second since the beginning of the universe? How can you possibly do
It's a
that?
haughty claim.
It really is, but they know how to back it up. So what they do is they'll compare the output of one strontium clock to another strontium clock, and the difference, the biggest difference between the two, they'll take that and say that
Right.
that's the discrepancy, right?
Mm-hmm.
And because these things vibrate at such crazy huge numbers per second, that the loss of like one or two waves over a second, it just adds up to these crazy huge numbers. So it lost one wave essentially for every 10 to the 10th power waves, which is like, I think 10 billion waves, right? So when you start adding that up to the number of seconds in a day, in a year, in a century, you suddenly realize, like, okay, this thing is not going to lose a second for, 15 billion years. That's how they do that.
Amazing.
Math is how they do it, I should say. Let's give math its due for once.
Yeah. All the maths, as they say in England.
For sure.
So we're going to explain how this works now. Kind of the remarkable surprise of it all is that these things, and I guess it's not much of a surprise because I mentioned it at the very beginning.
It could have been.
But they still use quartz as part of this system. It's a feedback loop that starts with a quartz crystal and ends up with a quartz crystal. And in between, this science voodoo happens that just is all about self-correcting as it feeds back into that quartz crystal to be, shot back out again in the form of microwaves.
Yes. And I'm glad that you really kind of stepped up and took charge here because when we're researching, we'll send especially day of stuff, we'll send just like little last minute details or maybe better explanations of something that we have when we're researching. And Chuck stepped up and was like, okay, let's not over explain this. This is actually kind of a simple thing in concept. And you rescued me from sheer madness.
It is our thing, though.
I had looked into the abyss and found atomic clocks just staring back at me. And it was something that you really rescued me from it, and I appreciate it. I want to say hats off to you.
Well, thanks, but we're not done.
Oh, God.
Like, there's still a chance to over-explain this into confusion.
Well, then allow me to try that.
All right, take it away, because it's all about this outermost electron, right?
Yeah. So with cesium, I guess then the reason they selected cesium is because it has 55 electrons. 54 of them are so tightly locked in orbit around the nucleus that they basically don't get excited.
Yeah.
That 55th outermost electron, though, it gets excited pretty easy, right? But it only gets excited when it's exposed to a frequency of electromagnetic radiations at specifically 9,192,631,770 cycles or hertz.
Or if you offered ice cream.
It gets kind of excited, sure.
Yeah.
But it may not fall out of its ground state. It depends. Is it Jenny's ice cream? Is it that butter cake, gooey butter cake? It's going to get excited from that one. Is it just, some dippy old, Breyers that's been in your freezer for several months?
Breyers. Poor
No,
Breyers.
no shade on Breyers, but if it sits there for a few months, it's going to form ice crystals. Nobody, even the cesium atom's not going to get excited by this.
Yeah, what was it in, did you see the Alfred Brooks movie Mother?
Albert Brooks, and yes.
What'd I say?
I think you said Alfred Brooks, and I think that's his butler.
Well, no, but now that we're off on this track, their original name was Einstein. Albert Einstein was his name.
No.
Albert Brooks' name, yes, because his brother was Super Dave Osborne, Bob Einstein.
Oh my goodness, yes, I forgot about that.
Obviously changed his name. But his movie Mother with the great Debbie Reynolds.
Carrie Fisher's mom.
That's right. Boy, we're just all over the place.
Yep.
There was a very funny joke about the ice crystals on the ice cream, and I can't remember what she called it, but something like a protective barrier or something that it forms, like to really preserve the ice cream underneath.
That's a good one. I feel bad for Fleischman from Northern Exposure because he has to play such a jerk and he does it so well.
Yeah. I saw an episode of that, a couple of episodes on our last tour, actually.
Chuck, have you seen the whole series?
I mean, I saw it back when I was a huge Northern fan, but then watched a couple. I watched the first two eps when I was in the hotel in one of our towns.
Mm-hmm. And how did it hold up?
It held up pretty good for a show of that era.
Okay, great. Fantastic.
Did you
I'm
like
glad
it?
to hear that. Yeah, I loved it. I was going to say, I think that the last episode was one of the best last episodes of any show ever.
I don't remember it.
Or no, okay, sorry, not last episode, Fleischman's last episode.
Oh.
When he goes back to New York?
Okay, I don't remember. Did he leave and the show continued?
Yeah, for a little while.
Yes, I don't remember. It's kind of like when Steve Carell left The Office, I was done.
Yeah, his last, there was some moments of brilliance in there in The Office after Carell left, but it wasn't reliably great every single episode.
Yeah.
And they got wackier and wackier as time went on, but that happens, especially when a showrunner leaves too.
How do we get sidetracked? I'm talking about the ice
crystals.
Talking
about, Mother. And by the way, I just wanted to give a shout out to the Alfred Brooks movie, Defending Your Life.
That's so great.
Far and away his best movie, if you ask me.
There's a really good documentary on him that's out now that Rob Reiner did, in case you're interested.
Okay, cool.
All right.
So we're back to cesium, and I was saying that it gets excited at that same frequency that it emits a photon at, right? Mm-hmm. That's what it takes. And so what they figured out is that you can find out if your quartz crystal oscillator, the thing that you're using to keep time with,
mm-hmm.
it's super reliable, but again, it's subject to frequency drift here or there. But if you can find out how far off or whether it's keeping reliable time by comparing it to the excitement of a cesium atom.
Yes.
If the quartz crystal is putting out the right frequency, the cesium atom will become excited and it will shoot off a photon. And if enough of them do that in this atomic clock, this gas chamber essentially that they have, then you know that your quartz crystal is keeping the right time because it's emitting the right number of pulses itself. The thing is, Chuck, and this is where the madness lies for me, I don't understand how they take 32,000 and change hertz coming from the quartz crystal and translate that into 9 billion and change hertz that excites the cesium atom. That's what I don't get. Do you get that?
Well, the way I understood it is that those two things are working independently. Like the cesium is doing its thing at 9 billion plus hertz.
Okay.
Just to get a more accurate measurement. And then it's sending that correction via another electronic signal. I think it goes into what's called a detector. That's to me where the magic is because I watch a bunch of videos, even kid science videos, and it just says it goes into the detector.
Yeah.
And then back out, feeding into the quartz again.
Right.
I don't know what happens in that detector. I mean, it's detecting.
Right. Yeah, I think they're actually tracking the photons. It's one of the beauties of it. And I think that's why they kept quartz crystal technology around, is because it releases radio waves and we can read those really easily. So that's one reason they kept quartz around. It keeps good time and we understand it really well. But this is where I'm thrown off. Like, are they comparing the number of ticks that the quartz is giving off to the number of ticks that the cesium atom is given off in that same time span? And if the two match, then you know the quartz is still keeping good time. If it's off a little bit, then you know how much to adjust it, because that cesium atom is not going to release any more waves than that number. It's just not. There's never going to be 771. There's never going to be 769. It's always going to be that 9 billion number. So I guess if you compare how many the crystal, which can have more or less over time depending on how well it's functioning, if you compare those two, then you know that your quartz clock is keeping fully accurate time. Is that what it is?
I think that's the deal. And all that it does once it reads, once those atoms are like, no, you're actually off a little bit, I think it just tweaks that original electric current in the feedback loop, feeding back into the quartz.
Right. It punishes the quartz crystal
in the form of a spanking.
It's like, no, it's like that one guy who's being tested for ESP at the beginning of Ghostbusters.
Oh, right. Yeah,
it's like,
exactly.
No, not again.
I mean, I think that's it.
Great.
Good night.
So let's talk about the second a little more, because I think we kind of jumped past it, and I think it's worth including the actual definition because it's so great.
Yeah. What is it now since the official change?
Yeah. So this is what they changed to in 1967. The second. They're talking about the second. Everybody who walks around is like, yeah, there's 60 seconds in a minute. This is the international definition of what a second is. It's the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. By the way, everybody, this definition refers to a cesium atom at rest at a temperature of 0 Kelvin.
Yeah. Wow.
So, but you're like, okay, that doesn't really make any sense. But now that you understand how atomic clocks work, it does make sense. They're saying if you have something that is timed to this, you have a second. That's a second right there. Everybody's going to be on the same measure. That's why it's the international standard. Everyone is on the same measure, and the cesium atom is never going to give out more or less of those waves when it's excited.
Yeah. And like you said, one of the reasons that quartz was used is because we had worked with it up until that point. We understood it. A lot of the tech was built around it. We've known how to work with it and repair things using it. So like they didn't want to reinvent the wheel here. They just wanted to make that quartz run more perfectly. And it turned out it was, sitting around in ore deposits in Maine and South Dakota?
Yeah, in
Isn't that where cesium comes from? It's pretty rare.
Yeah. And the other thing that strikes me about this, Chuck, too, was when we adopted that second in 1967 and removed our seconds from the solar day because it's so inaccurate, kludgy, really, we actually became better at tracking the solar day when we turned our attention to tracking the atom for use as a benchmark for time rather than the solar day. I just think that's pretty neat and ironic.
Yeah. I mean, they've calculated that too, right? Like, because now we have what's called International Atomic Time, TAI. It's one of those backwards
French things.
Yeah, backwards French things. But now we can actually track it using universal time and against the Earth's rotation and, the fact that we're off because, things can slow the Earth down. Space dust can, solar winds, atmospheric resistance, the moon, and gravity tugging on the Earth. So they can say now that UTC, Coordinated Universal Time, is 30 seconds behind the TAI.
Right.
Which is pretty cool to be able to know that.
Yeah. They're keeping better track of the spin of the Earth than the spin of the Earth is.
Yeah.
It's crazy. Like they figured out that the Earth is slowing down by about 2 milliseconds each day. Could not have done that when you're pinning the second to 186,400th of a solar day. You need atomic clocks to measure stuff like that. So I just think that's just fantastically neat. And they've done so many other stuff or so many other things with this already too. I say we take a break and we come back and talk about some of the applications for timekeeping in an ultra precise way.
Let's do it.
Stuff you should know.
Introducing the all-new Mazda CX-5. featuring more connection,
Hey Google, where's the nearest Pilates class?
safety that has your back, more discovery on the scenic routes, more passion in the details, and more control in changing weather. The all-new Mazda CX-5. More to move every side of you. See it in 5 films at mazdausa.com/5sides.
Google is a trademark of Google LLC. Sequences shortened and simulated.
Dell PCs with Intel Inside are built for the moments that matter, for the moments you plan and the ones you don't. Built for the busy days that turn into all-night study sessions, the moment you're working from a cafe and realize every outlet's taken.
Yeah, the times you're deep in your flow and the absolute last thing you need is an auto update throwing off your momentum. That's why Dell builds tech that adapts to the way you actually work. Built with a long-lasting battery so you're not scrambling for the closest outlet, and built-in intelligence that makes updates around your schedule, not in the middle of it.
That's right. They don't build tech just for tech's sake. They build it for you. Find technology built for the way you work at Dell.com/Dell PCs. Built for you. Everyone knows winter is the real mess maker. You don't need WeatherTech floor liners for summer unless you hit the beach and half the beach ends up back in your car, or the campsite dirt ends up in your trunk. Then you'd want a cargo liner, or a road trip goes sideways, lemonade spills, ketchup goes rogue, ice cream drips. Yeah, you'd be pretty happy about those WeatherTech seat protectors. So just to be clear, as the mud you're inevitably going to step in this summer, you don't need WeatherTech unless you plan on doing summer. Visit WeatherTech.com today. So, atomic clocks were a huge leap forward, but they were very big at first. Obviously, with all kinds of tech like this, it just gets smaller and smaller.
Mm-hmm.
I think about 20 years ago, they built an atomic clock that could be put upon a microprocessor.
It's crazy.
Totally crazy. And it's important to point out here that there are a little more than 400 atomic clocks all over the world and more than 70 labs operating these clocks.
Mm-hmm.
But you still need one ring to rule them all. You need one clock to tell all the clocks what time it is. So the International Bureau of Weights and Measures averages all these atomic clocks that are operating in the world.
Right.
It gives better weight to the ones that are really accurate. So if you got a gold star because your atomic clock in your lab is super accurate, you're going to be more heavily weighted.
If there's a lot of known pot users in your lab,
Right.
they're not going to weight it as heavily.
So, well, ironically, we'll see here in a minute, comes from Colorado.
That's right.
But it is, then they're like, all right, this is the real time for the entire world. And then they message that out as what I mentioned earlier, International Atomic Time.
Right.
And here in the United States, or I guess in all of North America, that is broadcast out from a radio station in Fort Collins, Colorado, WWVB, that all American clocks sync to.
Yeah. There's
radio control clocks.
Exactly. Yeah. So if you have an atomic watch or an atomic alarm clock or something at your house, it's actually passively picking up those radio waves from WWVB. And those radio waves are telling the clock what time it is. So it's keeping accurate time because it's getting the information from Radio WWVB, Radio Free Europe.
Yeah, but that's the time that they're like, all right, this is what time it is on the internet. And that's what time all your trains are going to run and your planes are going to take off and land.
Yeah.
Although those are always going to be late. But, if we're operating in space, if we're using GPS, and you can explain the thing you found on GPS because that was pretty cool. But all of it is set to that agreed upon average of all those atomic clocks.
Yeah. And so people have their own like timekeeping stuff. Like if you have an iPhone or like Android or something like that, whoever is serving that phone has their own time servers, but their time servers are still, if you trace it back far enough,
yeah,
they're getting their information from the atomic clocks that are being maintained, at least in the U.S., by the National Institutes of Standard and Technology. And then we also have to give a shout out to the U.S. Naval Observatory. They started it first, and they still maintain their own set of atomic clocks, and they are the official timekeeper for the Department of Defense. But they're also the ones that you can call to get the accurate time. And in the United States, you can call 202-762-1401.
Oh, man.
And you will hear the voice of a man from the 70s who died in the 90s who's still telling you what time it is. He apparently spent several days, Fred Goldsmith, I think.
What's that number again?
202-762-1401.
All right. I'm typing that into my phone because I had a weird urge about 2 months ago to call time like we did when we were kids. You could call and get time and weather in most places.
Yep.
All right. I'm glad to know that's a thing because I'm gonna do it from the phone that I know has all that information on it.
So yeah, I was reading like an AARP article on it, appropriately enough, and I think the actor's name is Fred Goldsmith, right? Yeah, that's where I get a lot of this information.
No. But are you getting mailers yet?
No, I found it on the internet.
Okay, just wait till you get your first mailer.
He apparently recorded every possible time it could be, including seconds, over the course of several days, and they still use these recordings to tell you what time it is.
Amazing.
One of the other amazing things I saw is like they just expected this to kind of go away once smartphones became so ubiquitous. People just didn't need it anymore. Your phone is automatically communicating with your server, the time server for your phone company. Nope. In 2009, they actually started to see an increase in calls. So now people call more than they did in the early 2000s today.
If you tell me movie phone is still around, I'm going to just quit my job and do nothing but call those numbers all day.
You remember when Kramer figured out that?
Yeah.
Or no, did people think he had the movie phone number, so he started being the movie phone person?
Yeah, I think that's what happened. And when he didn't know the answers, like they would be punching in the numbers, he would say, why don't you just tell me the movie?
That's right. Oh, my God, that was good.
So classic. Rated R.
Oh, man. I watched the Puffy Pirate Shirt episode the other day, and it still holds up. Yeah.
All right. So we promised talk of GPS. I didn't have time to dig into what you sent. So if you've got it together enough, can you explain briefly how GPS works? Yeah.
So you mentioned that some atomic clocks can be fit onto microchips now. And you can find those microchips aboard satellites that orbit space. And we have satellites that are dedicated to GPS, Global Positioning System, right?
Mm-hmm.
I actually found this. I got to give a shout out to Arpita Sarkar, who is just some random person on Quora who
we hope got it right.
Yeah, as long as they are not so masterful at mashing facts up and into lies essentially, but just covering it up perfectly, I'm pretty sure this guy got it right. But essentially, what they do is if you're like say you're using Waze or something, which I do use. Shout out to Waze, I love it. It has a onboard GPS receiver somewhere. I don't know if it's in the Waze server or something like that. Maybe it's using your phones. It's probably using your phone. And what it's doing is it's receiving a signal from the GPS satellite saying, here's a signal of some GPS info, but also here's a timestamp that came from my own atomic clocks that I have on board this satellite, right? And so your GPS receiver gets it, calculates how, using the speed of light as part of the formula, how long it took for you to get that. And then it does it again with another satellite and another satellite, usually 2 or 3. And based on all of the differences between how long it took for those satellites to send you that information, it can tell you within, I think, 10 feet or 10 meters, I think, exactly where you are on planet Earth, because it triangulates your location. And that's all thanks to atomic clocks. It wouldn't be possible to do that without atomic clocks.
Yeah. So, I mean, if you're geocaching, next time you get that Santana record out of the geocache, thank an atomic clock, thank cesium 133.
Yep.
Thank the good people of Maine.
And North or South Dakota, one of them.
I think it's South Dakota.
Was that a callback to like a 2009 episode? Is that what we said you could find in the geocache things? Man, Chuck, that
and for
is
a little while,
cut.
I think apparently for a little while, some people were, Stuff You Should Know listeners were putting Santana tapes and CDs
That's awesome.
in geocaches, but I'm sure that's run its course.
Yeah,
or maybe
probably. Not. Who knows? I'll bet there's some retro geocachers that are like, I got the Santana thing going on.
Yeah, I think I was saying geocaches. That's not work.
I've heard people say that before, although maybe it was you from that episode in 2009. I've heard people
some
say
dummies say it.
Yeah. What else can you do with this stuff, Chuck?
I mean, I think that's a pretty good summation.
Well, let me add one more thing. It's been used in physics experiments too. It's vital in physics experiments because you're tracking, like, say, the decay of particles in atom smashers, and that happens so fast that you couldn't do it without atomic clocks because they're tracking things in the billionths of a second, right? Mm-hmm. Pretty good stuff. It's also been used more than once to prove Einstein's theory of relativity, that there's gravitational time dilation depending on the effects of gravity on you and how fast you're traveling as in relation to the speed of light. Time's either going to move faster or slower for you. And so people have taken atomic clocks and put them at different elevations. There was a very
not even by much.
No, I think 30 centimeters for one experiment, and it produced differences in time dilation. But there was a really famous experiment called the Hafley-Keating experiment in 1971 where they put some atomic clocks on airliners and just flew around the world and then compared them when they got back to the clocks back on Earth, and there was a clear distinction between time. It's very, very slight, but it's enough to prove that, yes, Einstein's theory of gravitational time dilation is correct.
Yeah, like that old thing that you will age faster living in the mountains than at sea level.
Yeah, that old chestnut.
It is true, but I think what they found out was if you live in the mountains, it'd be about 90 billionths of a second less life over a 79-year lifetime. So
everybody's like, why bother? Why bother even telling us that?
Exactly.
There's one other thing, too. So we mentioned, we didn't mention, I'm sorry, I left this out. Those GPS atomic clocks that they have on board, very, very precise. They still get updates twice a day from back here on Earth, from those international timekeepers.
Yeah.
Just to make sure that the frequency drift hasn't taken over too much. It just updates them, right? You can't do that the further you get out from space. I mean, these satellites are only tens or dozens of miles above us, right? As we get further and further out into space, it becomes harder and harder to communicate with Earth and to get like updates about what time it is. So they're looking to build ultra precise atomic clocks that can go out in space on board spacecrafts that can keep their own time. They don't need any updating from back here on Earth. They're going to lose so little time over such a long period of time that they will essentially stay calibrated to the time back on Earth for incredibly long periods of time through incredibly long distances out into space.
Why haven't they done that yet? That was my sort of question.
Well,
Is
they
that
have
harder.
They have. NASA launched the Deep Space Atomic Clock in 2019, which is like a test that apparently is going very well.
Oh, okay. I was about to say, why don't they just throw one of those puppies aboard the spacecraft?
But they did. And they're using mercury ions instead of cesium atoms or strontium.
That looks even better, right?
It is, because so one of the things, these atoms, when you have them in like a cloud chamber or whatever, they can rub up basically against the sides of the chamber, and it's going to mess with them a little bit. It's going to mess with your measurement some. With an ion, you can keep it trapped in an electromagnetic field. It's not going to mess with anything. It's not going to rub up against anything. And so that's how it stays so reliable, how it's your measurements are going to stay reliable for a very long time because they're not interacting with, they're not bumping up against anything.
Yeah, they're not slam dancing. They're doing the Billy Idol. They're dancing with themselves.
Speaking of slam dancing, I went to Circle Jerks and Descendants last week, and it was amazing. And there were people. There was a pit for sure. I haven't seen one of those in a long time.
And did you look down and Yumi was body surfing across the crowd?
No, but she was into it. She was there for the Descendants. I was there for the Circle Jerks, but both shows were very good. And a fan came up and said hi at the show.
I think I saw that an email or something.
Yeah. She emailed and was like, I'm sorry if it was like awkward or weird. And I was like, it wasn't awkward or weird at all.
Yeah, I'm sure it was wonderful.
But it was a very good show. And if you have a chance to see Descendants and Circle Jerks and you like punk, go see it. Because it's
awesome.
It's very good.
Still at it. I love it.
Yeah. If you want to know anything more about atomic clocks, you can find a whole rabbit hole to go down. See if you can escape madness yourself And in the meantime, it's time for listener mail.
This is one that we've tried to get on recently. It's another Peanuts one, but this is a standout. Hey guys, Charles Schultz was a huge part of my childhood, though I never met the man. He spent a short amount of time living in Colorado Springs early in his career, and while living there, he painted a mural on the nursery room in the house that had many early depictions of the Peanuts characters. Years later, long after he moved out, my grandparents, Stan and Polly Travnicek, bought the house. Over the years, they heard rumors from neighbors that Schultz had lived there and painted a wall. At this point, the wall had been painted over several times, but my grandma was an amateur painter, knew a thing or two about paint. So after lots of deliberating and researching, she decided to try and remove the layers of paint over the mural, bit by bit, using cotton swabs.
Way to go.
Man, I love Polly Travnicek for doing this, because it would have been lost to time.
Yeah.
The wall and all the characters were revealed. Many of my childhood memories involved that wall. My grandparents, would even give free tours of the wall to anyone interested. And this gets so great.
Yeah.
When Mr. Schultz passed away, my grandparents reached out to the family, offered to donate the wall to be a part of the Schultz Museum. So the estate coordinated to have that wall literally cut from the house, loaded onto a truck, and shipped to California. I will never forget that cold, rainy fall day in Colorado. I was around 9 or 10 years old. The Schultz family treated my grandparents like cherished friends for years after that, and even flew them out first class to be there for the opening of the museum. Mr. Schultz was a wonderful man, had an amazing family, and made the world a better place. And that is from Mike DeYoung, and I saw pictures, and it's really pretty unbelievable. You can Google this wall and look it up, and I can't imagine the effort that his Granny Travnicek,
Nana Travnicek
put forth to tediously, meticulously expose that great work of art.
Also, Chuck, she was researching this at a time where you had to go to the library to find stuff like this out.
Sure.
And they were
could have ruined it.
Yeah, easily. It could have been like that Monkey Jesus art restoration thing. Remember that?
Uh-huh.
Okay, and I also want to point out that the Schultz Museum flew them out first class back when first class actually meant something, too.
Oh, burn.
So, there it is, the most triumphant, greatest Peanuts email we received from that episode. We got a lot of good ones, but Mike DeYoung took the cake. So thanks for telling us all that, Mike. And hats off to Granny Nana Travnicek and the whole family and the Schultz Museum. That was pretty cool stuff. If you want to get in touch with us like Mike did, we'd love to hear from you via email at stuffpodcast@iheartradio.com.
Stuff You Should Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.
Geico presents a 30-second podcast between your podcast. Today's story is shared by one of our listeners. It's called Betrayed by Bill. It was in that moment I caught who was staring back at me in betrayal, or more like what? My insurance bill. With trembling hands, I grabbed my phone and switched to Geico, saving about $900 in the process, and never to be betrayed again. Now that was bloody riveting.
It feels good when the story ends with savings. It feels good to Geico.
You know, you could be adored by everyone and still completely ignored by your cat. Trust me, I know. But if you feed your cat Sheba, you can go from being ignored to truly adored in 12 days guaranteed or your money back. Sheba has a full menu of products, appetizers, entrees, treats, even a kitten's menu. It's so cute. So Sheba has a product for even the pickiest eater. Like Sheba Puree, it's made with bone broth, they are chef-inspired flavors, it's got a smooth and creamy texture that cats love, and contains no corn, wheat, soy, or artificial flavors. It's food that your cat's gonna love. To learn more, check out Sheba.com. That's SHEBA.com.
Service opens doors, and at American Military University, it can open doors for the whole family. If you have a loved one who served in the military, you may qualify for reduced tuition. AMU offers flexible online programs designed to fit your schedule, so you can keep moving forward wherever life takes you. Learn more at amu.apus.edu/military. Open doors to the future for you and your family with the help of American Military University.
This is an iHeart podcast. Guaranteed Human.